A very good evening to everybody. Yeah, there we are. Why do you? What was the felt need for ADAS? That would be the first point which I'll be discussing in this presentation. I will be. By the way, what is ADAS? ADAS is Advanced Driver Assistance Systems, and we will see what are the various levels of ADAS. Level 0 to level 5, as I can tell you in the next bullet point over here. What are the 5 pillars of autonomous driving? In case somebody is interested of, sometimes let's assume that you all decide, hey, we want to make an autonomous driving car. So what all do you need to do? Again, very, very simple. If I leave a few of your ladies and gentlemen in a room, you yourself will come out with exactly what I'll be teaching or I'll be talking about with you in the next few minutes. Obviously, the next question, ladies and gentlemen, is what is the skill set required in case the youngsters want to make a career in ADAS? A very, very brief overview of what the Robo operating system is. Yes, at the outset, let me tell you, ladies and gentlemen, it's not an operating system. That's a misnomer. We will see what exactly it is. What is the sensor fit of a typical car? And then there are some extra slides. And time permitting, and if the audience shows some interest, then I'll take you to the next part of my presentation. And that is what is hardware in loop testing. Every few minutes, I'll be asking Professor Shirish Mane whether he can see my video and he can see my screen or not. Yes. So, Professor Mane, is it fine?
Yes, sir. Working fine.
Great. I hope my audio is okay. Do I need to make any changes?
No. It's great.
Okay. Right. Thank you. As I said, the first thing would be why ADAS. There is this report which is there. The references for the report are given below. And in 2014, it's a report of the United States of America that there were more than 30,000 traffic-related fatalities. People had died. More than 30,000 people died. There were about 2.3 million injuries and about 6.1 million reported collisions. And you'll be shocked to know that 94% of these accidents and injuries and collisions were attributable to driver error. It's a big number, but it's the truth. 94%. And out of that, 31% involved intoxicated drivers. Obviously, intoxicated drivers is absolutely a mistake of the driver itself. And 10% was from distracted drivers. So this made the scientific community sit up. Of course, work on ADAS was already going on, but this particular report somehow gave the confidence to the scientific community that yes, what they are doing is the right thing, and we need to start looking at ADAS in a much more focused manner. By the way, this report was published by the National Highway Traffic Safety Administration. The short form we all know. It is NHTSA of the United States of America. Before I go ahead, so what have I done? I've just talked to you what was the felt need. Before I go ahead, I will just tell you a representative list of ADAS features, the kind of features which we find on cars and so on and so forth. Like there is adaptive cruise control. The names are very, very intuitive. I mean, you don't even need me to explain to you. So for example, adaptively, where I can control my speed. We all know since the last so many years, there is this cruise control which is there. You set a speed on the car using a small button, and you are on a highway, so you're traveling from Bombay to Pune, and then you set a particular speed, and the car will keep going on that particular speed. Say 120 kmph or 80 km. You can remove your leg from the foot pedal, from the accelerator pedal. It will keep going at 80 km. That's normal cruise control. But here we are talking about adaptive cruise control. What if the car in the front is slowing down? So will your car slow down from the set speed of 80 kmph to say 60 or 40 or no? And when that particular car has again sped up, will it increase speed from 40 to the set speed of 80 kmph? So that is adaptive cruise control. So I will, at this point, I'll pause for a couple of minutes, and I would like you, the audience, to kindly have a look at the representative list of ADAS features which are flashed on the screen for you. What you can do, ladies and gentlemen, the whole lot of youngsters who are there, that you can go to Wikipedia and just possibly type one of these features, and you will get a lot of information about that. Or you can go to YouTube and see these kind of features which have already been implemented by the leading OEMs of the world. What is OEM? Original equipment manufacturers, like for example the Hondas, the Toyotas, all these the Ford, the Mitsubishis, all these people, all these companies who make the cars. They are called OEMs in our terminology. By the way, talking about terminologies, Professor Mani, that KPIT per se is sometimes a tier one and sometimes a tier two. What's a tier one company? Tier one company is a company which actually makes systems directly for the OEM. So many times we have projects where we are directly talking to Honda, we are directly talking to Toyota, so on and so forth. Tier 2 is something, a company which actually first talks to a tier 1 or develops a product for the tier 1, and then the tier 1 is actually talking to the original equipment manufacturer. Coming to the next slide, what are the levels of ADAS? By the way, these 6 levels of ADAS were outlined in the SAE document number J3016 document. And what is level 0? Level 0 is nothing but the driver controls it all. The steering, the brakes, the throttle. It's something which you have been doing all along. One second, I'll just pause for a moment. Sorry, there was some background noise, so I thought I'll go and tell the family members to kindly pay some, yeah. Okay, so that is what you've been doing all along, as you can see on the screen. And only alerts are issued by the system. For example, what you already have in your cars, that when you put your gear lever into reverse, and in case your car is going towards an obstacle, then there is this beeping sound which comes on your infotainment console. Then we go to level 1. Level 1 is most of the functions are still controlled by the driver, but a specific function, either lateral or longitudinal function. When I say lateral, I'm meaning left and right motion. Longitudinal is front and back motion, is done automatically. Like for example, I was lucky to be working on a feature for Jaguar Land Rover, and that feature was automatic park assist. Now there was only automatic steering. So you are entering a parking lot, and the moment you enter a parking lot, you are like keeping your hands off the steering, and the vehicle is going straight into the parking lot, right? It has ultrasonic sensors, 6 sensors in the front, 6 sensors at the rear. These sensors are sensing whether there are empty parking spaces, number 1, and whether these parking spaces are wide enough for your car to get in. If it realizes it is, then it stops, and then it gives you an alert on your infotainment panel. It's called the infotainment panel. And then you are expected to either put the gear lever forward or rear. And the moment you change the position of the forward or reverse here, and then you're expected to press the pedal, and then automatically it will take you back, right? So as I said, the left and right motion was done by the car, but you were expected to change the gear lever, and you were expected to press the accelerator. So this is the park assist, but level 1. Now the same feature, ladies and gentlemen, can be a level 2 feature. So the feature is same, but here the car will do both the left and right motion as well as the forward and reverse motion. What is level 3 ADAS? Level 3, driver is still necessary, but the driver is able to shift most of the safety critical functions to the vehicle. However, there is a small disclaimer: only under certain traffic conditions. Say, for example, to give you an example, you want to go from, say, from Shivaji Nagar in Pune up to Worli in Bombay, right? So you know that when you're starting from Shivaji Nagar in Pune, you have to go to the beginning of the expressway. Now, till that place, till that point on the expressway, the driver can drive. But the moment you are on the expressway, then the vehicle can be fully automatic. Everything will be done by the vehicle. But up to where? Not up to Worli. Again, up to the end of the expressway. And then the moment the expressway gets over, you have to again, the driver has to again come and start operating the vehicle, right? So under certain traffic or environmental condition. That's the keyword over here. But otherwise, it's fully automatic, right? Coming to level 4. Level 4 autonomy, again, fully automatic. However, driver is still present in the car. You have to have him. The automatic system can perform all safety critical functions and monitor roadway conditions for the entire trip, right from Shivaji Nagar in Pune up to Worli in Bombay. The driver can, possibly play with his child. He or she can work on the computer, watch movies, so on and so forth. But in case there is a condition wherein the system feels that the system cannot handle the situation, there will be an alert issue and the driver is expected to take over in the next 5 or 10 seconds. So that is an important point to consider. However, in a level 5 ADAS car, everything is automatic. In fact, you don't even have a driver, you don't even have a steering wheel. So your grandmother, she orders a car on her app, and the car comes to her doorstep, and there is no driver. She just sits and she goes away, right? That's what the holy grail of autonomous driving, if I may say. Coming to the next, so I'll just go back and pause here for about 30 seconds. I will wait for the audience to understand what is level 3, level 4, level 5, and I will also go and show you what is level 0, level 1, and level 2. Right. Coming back to the next, so what have I covered till now? Not much. I have talked to you about what is the felt need for ADAS. And then I've talked about the 6 levels of ADAS, starting from level 0 up to level 5. Now, as I said, what if a few of you youngsters decide that, hey, we need to make an autonomous driving system? Then what I would do is that I would just ask you to close your eyes for a moment and just imagine that when you are driving a car, what exactly are you doing, right? So obviously, whatever you are doing, you are expecting a system to do that, is it not? So what are you doing? First of all, you're sensing. Your eyes are there who are sensing what is there on the road. Your ears are there, you're hearing what is happening around you, right? So primarily these are the two organs, two sense organs which we are using, our eyes and our ears. And then there is a whole lot of processing which takes place in your brain. Your brain, since childhood, is able to correlate what your eyes see with what you hear, right? So you are able to make out that, yes, okay, I see that particular car which is honking. So I can hear the honk and I can see the car. So that is that particular car, because your ears are also able to localize. We know that our ears are able to localize whether the sound is coming from here or it is here. Even if you close your eyes, you can localize the source of sound. So the first step is sensing, which now you expect your system to do. And also sensing, you have a host of sensors. We'll talk about the sensors. The sensing has to be done in a time synchronized manner, and the data has to be fused. Your brain does it automatically for you. It does the fusion of what the eyes are seeing and what the ears are listening, right? But here, now you expect the particular system to do that. To give you an example, you have a camera mounted on your car, and the camera is seeing a particular backside of the backside of a particular vehicle. Your radar is also seeing that particular object. You know that the radar and the camera work very differently. So the radar is also able to detect that particular target. Now you require a system which is able to fuse or combine the information coming from the radar and coming from the camera, and give that one information to the central processing computer, or in our language we have to generate one composite information plot to the central processing computer. Now this central processing computer knows all the targets, all the pedestrian targets, all the stationary targets, all the moving targets which are around the vehicle. The keyword here, ladies and gentlemen, composite information plot, or CIP as we call it in our language. One is, sensing the information. Another thing is perception. How do you make sense out of the information? I just mentioned about the common information plot, or the composite information plot. Another level of perception is, for example, you have done done a lot of miles in a car, and you know that, say for example, if there is a boy on the side of the road, there's a very high probability of that boy running in front of your car, compared to if there is a man, or compared to even if there is an old man who's walking on the side of the road. So a man walking on the side of the road, very high probability of he coming in front of your car. An old man, reasonably high probability. The man, very low probability. An old man, a reasonably high probability. But a child has got a very, very high probability that it can come in front of your car. Right? So this is all in the domain of perception. Localization, very simply, where am I and what and who is around me. Planning, as we all do, long-term planning. You want to go from place A to place B. You decide that, I will take that particular street, I will take a right on that intersection, and so on and so forth, from my location to that particular destination. That is long-term planning. Short-term planning, hey, I can see a car there, I can see a car here, and there is a little path which is possible, which I can just navigate and go. That's called short-term planning, right? Obviously, you have to control, because here it's an automatic car, subject to known constraints. Why am I using the word? Say, for example, you are in a small car, say a hatchback. So you know what is the power available in a hatchback, compared to a situation that you are in a truck, or compared to a situation that you are in a sports car, right? So what actions you have to take, or what actions you can take, also depends upon the type of the vehicle on which this autonomous system is getting implemented. Say you are implementing an autonomous system in a truck which is carrying a load of 20 tons. So obviously you know that my stopping distance will be very, very large. So the central computer have to give that information to the brakes much more in advance, compared to if this autonomous system is being ported onto a small hatchback, because a hatchback is less than 1 ton and it can stop immediately. But a 20-ton truck will take a lot of time before it can go and stop. The next part under control process, Girish, is how can I react to changing situations? As drivers, we do that. How can I react to changing situations? That's the key word. That's called object and event detection and response. Object and event. I'm able to detect the objects and the events, and how do I respond to them? So before I go ahead, I will stop here for about 30 seconds, and I would like you to just look at these 5 pillars of ADAS. Professor Shirish, may I go ahead, please?
Yes, sir. Please go ahead.
Okay. I'm sure the young audience would be keen to know that, hey, Shishir, we are We are very excited because especially now you've told us what the 5 pillars of ADAS is all about. And hey, it's all very simple. I mean, what's new you're talking about? And I agree. If you had devoted about half an hour to this, you yourself would have come out. Yeah, I mean, we're required to know all this. I mean, we're required to do all this in an autonomous car. So fine, we understood that. Now, what do we need to do if we want to make our own ADAS or an automated car, autonomous car? So this is the required skill set. I'm sure you would have already understood that you need to have a very strong background of calculus, of linear algebra, of probability theory, estimation theory, and deep learning. You can have a slight prefatory exposure. You should know what deep learning is all about. You should know what estimation theory is all about. Of course, there are programs, there are various libraries which you can exploit, but you should at least know what do these various things do. Newtonian mechanics, very important, right? Fundamentals of control systems. Obviously, you are designing a control system, so obviously you should be clear about Fourier transforms, Laplace transforms, continuous and discrete time signals in systems, and linear time invariant system analysis should be very clear to you. Embedded system design, you've already created an algorithm, ladies and gentlemen, in MATLAB, but now you have to finally port it onto a standalone processor, right? So you should know how can I optimize and port it onto my processor. For all you know, you have made a very, very good algorithm in MATLAB code, Professor Shirish. But what if that particular algorithm takes a lot of time to execute on this standalone processor? And what do, you have to have multiple iterations of approximations, right? And then you have to see that, hey, I have done this particular approximation so that it runs in near real time on this target processor. But whether this approximation, is it allowed or is it not allowed? Whether it's going to result in a crash or a suboptimal performance, right? So this is where your knowledge about embedded system design comes in. Very good C++ coding skills, because the code which you've written in MATLAB or C++ that has to be ported onto a standalone processor. Exposure to Robo operating system and very good communication skills. I mean, I'm so thankful to Professor Shirish that he has given me this opportunity to speak to these young boys and girls. A lot of these boys and girls, they join our company. And there is one thing which our people are really lacking, I don't know why, is that they have very poor communication skills. They are just not able to communicate their thoughts. And I've been told that the audience is second-year students, and that's the right time, Professor Shirish, that you could have introduced me to them. I would really request all of you that you have to improve your communication. This is the time. You have to take it on a war footing. You have to be able to speak in good English and be able to talk to each other and communicate with each other. मराठीमध्ये बोललो तर जर्मनीच्या माणसाला मराठी येत नाही राव. त्यांना नुसतं इंग्लिश येते. ठीक आहे. फ्रान्सच्या माणसाला मराठी येत नाही, त्याला नुसतं इंग्लिश येते.
Excuse me, sir.
Only English. Yeah.
We have participants from around 16 states.
Yeah. So yeah, I was just trying to speak in a vernacular language and trying to tell my people that you need to start working on it right now. I mean, you have to take it on a war footing, do whatever it takes. I keep telling my people that even when you're talking to your friends or you're talking to your roommate, you please speak in English. I mean, that's all I can request. Sorry, I'm stressing this point a bit too much. A never give up attitude. Now you will look at these so many points which I have written on top, and you might wonder, oh my God, I don't know this, I don't know that, and what is Dr. Shishi telling us, and just not able to do all this. But don't worry, you are in a generation wherein everything is at the tip of your fingers. There are such beautiful videos on any topic. It's just that you need to have that particular desire in your heart that come what may, I am going to understand this. I often give this example, Professor Shirish, that, I have these youngsters who come, even people who have joined my organization, and they come to me. And just to give an example, I ask them that, hey, do you know how to take out the minima or the maxima of a curve? They, yes, sir, we know how to do that, and they will do it, and they will solve it and show it. But if you ask them, that, hey, why did you do this? Or why did you check whether the double derivative is negative or positive? And why is it, that for a double derivative, for a negative double derivative, it's a maxima, and other way around for a minima? They will not be able to answer. Such a simple question, they will not be able to answer. Why? Because they have stopped asking why. They know how to do things, but they don't know why they are doing it. That's the biggest problem. And then you can never be an innovator. You'll just be a follower. You can never create anything new. Because to create anything new, you need to have an intersection of two domains. Only then you can innovate. Another example which I give Professor Shirish, I give a question on double integration. They will be able to solve, in next 10, 15 minutes. But if I ask them that what does that double integration convey to you? Nobody, I can use the word nobody knows what is the meaning of that double integration. Maths is nothing but a language, You have to learn the grammar of the language. If you don't, any equation given in front of you is a long and beautiful story. You have to understand that story. The moment you understand the story, believe you me, Professor Mani, I do not mug up any equations. Why? Very simply because I have understood the story. You go and watch a movie. Do you need to mug up the story of the movie? No, you have to just internalize it. The moment you internalize it, you can tell the story of the movie to anybody. That is what a mathematical equation is all about. Right. I know I'm devoting a lot of time on this particular slide. It is because I want the youngsters to understand that anything is possible. If Oppenheim can write a book of 1,000 pages on signals and systems, you and me can definitely understand it. Another example, ask yourself questions that when Fourier transforms were already existing, why did Mr. Laplace invent the Laplace transform? You look at an equation, say for example, if x of t has this x of f, and if you do x of t minus tau, then x of f becomes x of f e raised to minus j 2 pi f tau. Ask yourself, why does it become like that? And that is where I feel that, my boys and girls are lacking. And this is the most appropriate time for them to sit up and they have to realize that, hey, I am an engineer, I'm just not a follower. Please do that. And anyway, let me not take too much of your time on this particular slide. I will go ahead. And what have we covered till now? We've covered the felt need for ADAS. We've talked about the 5 levels of ADAS. We talked about a very important slide where we talked about the 5 pillars of ADAS: sensing, perception, localization, control, and sensing, perception, localization, control, and I'm sorry, even I forgot. Yeah, there you are. Yeah, planning. Yeah, how could I forget planning? So it's sensing, perception, localization, planning, and control, right? So these are the 5 pillars of ADAS. And let's go ahead. And yes, if you have to make an autonomous car, then obviously you need to have good team skills. So divide your job and do what, right? What is the Robo operating system? As I mentioned right in the beginning, Professor Shirish, that it is not an operating system. Yeah, the name is a misnomer. It is basically a global collaborative initiative. So the keywords have been underlined, Professor Shirish. It's a collaborative global initiative to reuse your existing hardware components and software components and drivers and proven software code, whether it can be a C++ code or Python, for what? For various functionalities. So Fusion code is already there. Hey, I have data coming from different sensors. How can I synchronize them? Don't worry. The code, the proven code is already there. So you are not wasting your time. It's like, if I may use the word, the difference between MATLAB code and a C code. Right. What is MATLAB? MATLAB is nothing but a very rich library of some, I think, 20,000 functions. So you are not kind of reinventing the wheel. You just pick up Reed-Solomon coder, it's there. You just pick up Kalman filter, it is there. You just pick up unscented Kalman filter, somebody has done the dirty work of writing that code and proving that that code works. That is the similar thing about the Robo operating system. What it does, it compresses your development cycles. Apart from that, it has the various following features. I'll stop here for about 60 seconds so that audience can read what is there on the screen, and then I'll go ahead. Right. In fact, ladies and gentlemen, I have shared these slides with Professor Mani, and
So I believe that
there's
you're also
nothing.
reading the chat. Generally, I request the expert to just concentrate on the slides and not the chat. But like rightly you said, I will share these slides with all the participants tomorrow, because I believe many people are also writing down or taking notes. So I request all the participants, you can concentrate on the slides and what sir is delivering, and tomorrow you'll get a copy, because in fact you are the first expert to share the presentation with me. So tomorrow's email I'll send them these presentations.
Yeah. I mean, absolutely, and it's kind of my passion, Professor Mani, that I would like to spread the message amongst the youngsters, and about all these things which I taught. In fact, I'm realizing that I am also at home and my daughter is also at home, and she's troubling me with a lot of fundamentals of maths. So I don't know, possibly I might start a channel where I will be covering all mathematical topics in linear algebra and probability theory and differentiation.
That would be great.
Let's hope. No promises. Nothing has been done, but let's see.
Yes,
I
sir.
don't know whether I'll be able to take out time or not.
Yeah.
Okay, right. Right. In fact, I mean, on a lighter note, I even go to colleges and I meet the teachers in mathematics speakers and all, and I teach them as to how they should teach mathematics, so that the kids are able to appreciate in a much better manner. Whether you talk about 11th standard or 12th standard, even in very good schools, Professor Shirish, I mean, the way maths is taught is, I really don't appreciate the way it is taught. Anyway, or even for that matter, engineering subjects, some places is really taught in a manner which really requires a lot of improvement. Anyway,
we would
let's not go on to that particular part. Let's get back to our slides here. So we talked about what are the sensors. I know there was a passing mention about what are the various sensors. So there are a lot of external sensors. When I say external, means they are sensing what is external to the vehicle, to the car. By the way, ladies and gentlemen, also remember that when you say car, I may use the word car, but you have to expand your thinking, ladies and gentlemen, and imagine drones also. In fact, there is a lot of thought process which is happening in the industry, Professor Shirish, is that possibly the industry should have looked at drones a lot earlier.
Yes.
Right? Is it not?
Yes.
Because that's going to happen. Drones are going to come in. So please do not restrict yourself only to cars. Please, ladies and gentlemen, start looking at drones, and you will definitely have the first mover advantage if you start looking at drones right away rather than autonomous cars. Okay. So what are the external sensors? Sensors, a group of sensors, ladies and gentlemen, which rely on the radiation of an electromagnetic signal into the environment. Please remember radio waves, right? We all know what are radio waves, but remember that light is also an electromagnetic radiation. It's just that the frequencies happen to be in a range which can be sensed by our eyes, right? So when I say talk about electromagnetic signals, I mean light also. I mean laser also, right? And that is why you can see lidars. Lidars are nothing but lasers. Some terminology. So when I talk about radiation of electromagnetic signals, sorry, I'm repeating, I mean radars. So you send a pulse of radio energy or electromagnetic energy. That pulse, a small short burst, if I may say, like this, goes into the environment, it hits, if there is a target, it hits the target and then it comes back to you. So, you know the speed of light, or the speed of electromagnetic signal in the environment, the two-way travel time has been recorded by you, the distance. Again, that's how bats navigate in the caves. Of course, they do not use radars. They are using what are known as sound waves. And the difference between radars, between electromagnetic signal and sound signals. Sound signals require a medium, either air or water or solids, to propagate, whereas electromagnetic signals do not. We have electromagnetic signals coming from the distant galaxies. We have sunlight coming from the sun, wherein there is vacuum all between the earth and the sun. But still we can have those radio signals or light signals coming to us. Some terms, what is azimuth? Azimuth is where it is with respect to the heading. 30 degrees right, 30 degrees left, so on and so forth. What is bearing? Bearing is again angle or azimuth. What is elevation? Elevation is this, how much it is up. What is range? Range is this, the shortest distance between you and the target. Relative velocity, clustering, etc. Right? Again, I'm just throwing some terms at you. We talked about radars and lidars, ladies and gentlemen. Now what am I talking about? I'm talking about acoustic signals. I just mentioned acoustic signals require an environment, right? But if those signals are within our audio range, everybody will get disturbed, is it not? So in cars, what we use is ultrasonic signals. The frequencies are very high. We cannot hear it, right? That's the only difference. But otherwise, it's a sound signal at heart. Cameras. You have a camera which is mounted. Many cameras, in fact, Professor Shirish, and the front camera is typically a stereoscopic camera. I hope you know what's a monocular camera and what's a stereoscopic camera. Stereoscopic camera is like our eyes. There are two cameras, right? They look at the same object, and because they look at the same object little differently, the left eye and the right eye sees it differently, you are able to get a judgment of depth. I'm sure you must have felt sometime in your life that if for example, if you hurt your eye, if you put an eye mask on that particular eye, and if you try to play cricket, you'll never be able to play good cricket. Why? Because you will just not be able to judge the depth of the ball. So we get a vision or a feeling of depth just because we have two eyes, right? Obviously, all these cars are connected to the GPS. They have connectivity with the mobile phone, right? And they are also connected to a central server. At this point, Professor Shirish, I would really like to talk about a very interesting feature which was there on a Jaguar car. And that was, say for example, if you are stuck up on a hilly road and you have to negotiate a very tight curve, and you are scared that, hey, I will not be able to negotiate that tight curve on this hilly road, you can actually get out of the car and you are establishing a Wi-Fi connection with your vehicle on your mobile phone, and you are actually seeing what the top camera is seeing in the front of the car, and you are able to, like James Bond, you are able to negotiate your car through that tight spot, right? So here you are in the middle of the forest. There is no connectivity to the internet. Nothing is there. No mobile communication. Nothing is there. But you have been able to establish a Wi-Fi link between your car and your mobile phone. And that is what I'm trying to tell. And then, yes, obviously, your car also is connected to the central server of the manufacturer. And a whole lot of data is getting sent to that central server. And that data, ladies and gentlemen, is utilized for many things. More importantly, hey, when is the next servicing due? Hey, this parameter of this particular engine we are consistently seeing is very, very high. So there is something wrong with your engine. You please, the earliest time, please go to a particular service station and get your engine checked, so on and so forth. As we call it, preventive maintenance, right? So lot of things are possible. In fact, they are happening. What I talked about till now was all the external sensors, if you can see on the top part. The bottom part, we are talking about the internal sensors which are there on the vehicle. The wheel speed sensor, the yaw rate sensor, the tilt sensor, whether your car is like this or whether the car is like this. The steering wheel angle sensor. What is yaw rate sensor? Yeah, by the way, I should tell you what is yaw. Yaw is this motion of the car. Roll is this motion of the car. and pitch is this motion of the car, right? So here we are talking about the yaw rate sensor. Now you might, and it's required. I mean, just to take a digression at this point, when does the driver know, or when does the car know when the car is skidding? He comes to know when the car is skidding because there are two inputs coming to the car, Professor Shirish. One is the yaw rate sensor. This input is coming to the computer, and the other is from the steering wheel angle. So if this angle and this angle is not correlated in a certain manner, the car comes to know that, hey, the car is skidding. Right? So many interesting things are there. I mean, 1 hour would be a very less time to discuss so many things which are there. But again, as I said, it's no rocket science, right? 4 of you will sit down together. You will come out with all this knowledge which I'm talking about. I think at this particular slide, I can go a little fast. Again, yeah, I would really like to take this point and discuss with you that don't think that everything and anything which is there on the internet is right. Like, for example, how the electromagnetic field propagates. There is an E field vector and there's an H field vector. And we know that they are out of phase by 90 degrees. However, if you see the diagram on the right-hand side, it's showing that the E field vector and the H field vector, they are in phase. So I was really amazed to see that even on the internet, there is a whole lot of, wrong and misleading information which is there. This diagram on the left-hand side is very interesting. I mean, somebody from the audience could have asked me that, Commander Shishir, why is 77 gigahertz is the frequency which is being chosen for the radar of the car? And the answer is right here. See, if you can see, what is on the x-axis? Sorry. The x-axis is the frequency in gigahertz. So this is 10 gigahertz. It's a logarithmic scale. And this is 100 gigahertz. This is the attenuation because of oxygen in the environment. Attenuation of what, ladies and gentlemen? The electromagnetic signal, which is going from the radar. You know how a radar operates. It emits a burst and it comes back. So here, there is a nice little dip. So that means around these frequencies, the attenuation is quite low. And that is what the engineers have realized it. And that's why they decided that, yes, all the automotive radars will operate at around 77 to 80 gigahertz of frequency, right? So that is what I meant. That always keep asking questions. Why 77? Why not 60? Why not 50? And that's the reason. See, this is 10, 20, 30, 40, 50, 60. If you end up using 60 gigahertz, you're using a very, very bad frequency because the attenuation because of atmospheric oxygen is the highest over there. Right. Now let's, one part of the whole process of learning is, just reading books and blah, blah, blah. Another part is, how can you actually get down and doing things? And that is where the different professors of the different colleges come into play, or the group of colleges can get together that, hey, let's have some competitions. In fact, you'll be shocked to know that it is the DARPA challenge, which I think started in 2006, which resulted in so much of development in autonomous driving. So the last 14 years, every year there would be big colleges, the Stanfords and the MITs and the big colleges of the universities of the world would take part in these challenges. And that's how year on year, they have really been amazing improvements in the field of autonomous driving. So some projects, suggestions or challenges, if you can say, is this remote control parking of a car. Right. So, it's as if there is a room in which some kind of a sand model has been made and the people are connected to their car over a wireless link. And you cannot see the car because you are in a different room, but you can see what the camera on the car can see. Okay. And you are expected that how you are able to park these cars in a parking lot. Right. So that is what I'm saying. Aim is to accomplish n number of remote parkings in a physical sand model or a miniature racetrack. Remote control is in a nearby visually opaque but RF transparent enclosure. You can use combination of ultrasonic sensors and one camera, and remote control should preferably be over Wi-Fi or 4G. and the team taking the least time is the winner. In fact, Professor Shirish, I can also tell at this stage that there is a very strong user case of having control of cars over 4G or 5G. So if your students can work on how using 5G technology, of course, unfortunately, 5G is not yet rolled out, but somehow if you can have it in a lab setup, I don't know whether that's possible or not. So how over 4G or 5G we can do remote control of a car. Say, for example, another challenge which you can have amongst your group of colleges, autonomously traversing from one point to another in a known region, right? So the map of the surroundings or of that so-called miniature racetrack has already been given to the participants, and they've been given 3-4 months to work on it. And what are they expected to do? That finally their vehicle will be placed in that area. It's a sand model. Sand model means all these blocks and everything are there, right? And using a combination of ultrasonic sensors and rudimentary camera, you leave the car anywhere in that sand model, and the car is able to reach a particular destination on its own. Very interesting. Why? Because you will have data fusion, you'll have control, you have image processing, so many things the kids will learn while they are trying to prepare for this particular competition, right? Another thing that, hey, okay, fine, I had given you the entire model of the plan view of this particular racetrack, and now while the car is traversing, we will have some unknown objects, dynamically moving around in that space. And now you're expected to still, in spite of these, pedestrians going around or other cars going around, you are supposed to go from one position to the final destination, something like that. Okay. Yes. So, you might wonder, my God, so many things Commander Shishir has talked about. What next? He talked about one should be good in maths and Newtonian mechanics and algebra and so on and so forth. And if Fourier transforms and Laplace transform, blah, blah, blah. But what should be the starting point, right? I would say that fortunately for us, there are very beautiful videos which have been made by University of Toronto as part of Coursera. And it is there on the internet. And if you guys, if the boys and girls can go there and start looking at these videos, I think that would be very good. 1 minute, please. Just a second. So since I'm sharing these PowerPoint slides with you, you can have a look at it, that what these different videos are all about. And you will understand, my God, it's really been structured very, very well. At this point, I would also like to tell you that, it's always advisable if you sit down together and always work, whether you're watching a video or you're solving sums or anything, what you're doing, it's always advisable that you sit down and study together, work together. Because you will keep asking questions to each other, and and simultaneously you'll become good communicators also. And there is a saying in Hindi. It says "ek aur ek 11." I really feel very, very strongly. Even at office, I insist, Professor Mane, that my teams always work together. And not only me. And where did I see it? I saw it at BMW when I was at Munich. At BMW, even they insist pair working, pair programming. They do not have a system where people are sitting alone and working. They're always working in pairs, or they're working in mobs. That is the way the big companies of the world are working together. Right? I think these are the extra slides. They are there with you, and kindly go through them. And what we'll do, Professor Shirish, is that I think today there has been again, it's my fault that, or rather I would blame it on Mr. Murphy, who ensured that my Outlook also doesn't work, who ensured that my Gmail also doesn't work, and I ended up 15 minutes late. Yeah. Luckily, my daughter was hanging around, so I could at least log into the presentation. Yes. But what I will suggest is that this topic of hardware and loop testing, hill testing, is quite a big one. And it can't happen in the next 15-20 minutes. So I'll pause over here, and we can share some questions if there are any questions. We will have a look at those. Before I even go there, very quickly, I will just go to the first slide so that the audience has a very quick revision of what I covered. As you can see, the second part was hardware in loop testing. What was the felt need for ADAS? A representative list of some ADAS features. The 5 pillars of autonomous driving. What is the Robo operating system? Example of external sensors, the radars, the lidars, how a radar and a lidar is nothing but an electromagnetic signal, how an electromagnetic signal doesn't require any medium, whereas an acoustic signal, that is sound waves, do require a medium. Cameras, GPS, mobile connectivity, Wi-Fi connectivity, internal sensors. I took a use case for Professor Shirish, that how using these internal sensors, you are able to actually find out, just as an example, that whether my car is skidding is not or not skidding. Why? Keep asking. And something to generate interest amongst the audience. And, while they are working on a problem statement or on a competition, I'm sure, their progress while learning will be much faster. And these are the extra slides. I know I didn't devote much time to that, but you can just go through this and you'll understand. Right. So I stop at this stage and